Yes, we can start. Yes.
Okay. Okay. So, brief introduction of Mr. Darshit Prajapati. Mr. Darshit Prajapati is currently working as a senior executive engineer at Xylem Water Solutions at Vadodara. With over 7 years of experience in new product development, focusing on electronics-based applications and intelligent solutions. He has previously worked with ABB and Crompton Greaves, contributing extensively to industrial electronics product development with more than 17 years of overall experience. His expertise spans industrial electronics, system design, and reliability focus engineering. Uh, so welcome, Mr. Darshit Prajapati. Now you can start your session. Okay, thank you.
Thank you for inviting me. Let me share my screen. Is it visible?
Yes, yes, visible. Yes,
Fine. So you can see the first page of the slide.
yes, yes. It look good. Yes, fine.
Okay, fine. Fine. Let
Oh,
me start from here.
yes,
So good evening all. Within the Xylem, I am associated with engineering and the new product development team, where I work on the electronics-based systems and the intelligent solutions. My role involves developing and integrating a smart electronics, sensing, and the data-driven features into a product area that closely connects to the today's topic of conditioning, monitoring, and predictive maintenance. So welcome you all once again. Let me start with some details with the Xylem. Xylem operates across the wide range of product brands and the solutions portfolio, including the pumps, motors, controls, sensors, analytics, and the digital platforms. These solutions serve a water infrastructure, industry, commercial, and the residential applications with a strong focus on energy efficiency, reliability, and the sustainability. So let's have a look on this video. Is the voice of video audible?
No, sir.
So with this, I would like to take through the different brands where the Xylem is associated, that is across the globe. And I'm very much associated with the applied water, that is a clean water business, where I'm responsible for the new product development. So moving to the today's topic, that's condition monitoring and predictive maintenance using the ML technique. In the industry world, every minute of unplanned downtime can cost tens of thousands of rupees, dollar, or the currency of that country. Traditionally, we either waited for machines to break or replaced parts while they were still perfectly fine. But what if the machine could tell us exactly when it will be going to fail? So what is condition monitoring and why it is important? Let's start by understanding what condition monitoring really means. The condition monitoring, or the CM, I would say in a short form, is proactively maintenance strategy where we continuously and periodically monitor the health of machinery instead of waiting for a failure to occur. We track key parameters and look for a significant changes in a behavior that indicate developing a fault. The important idea here is early detection. By identifying issues at the early stage, we can take a corrective actions before a breakdown happens, reducing unplanned downtime and maintenance cost. That's the objective for this conditioning and monitoring. Now, why it is necessary? So monitoring helps us convert a raw science data into actionable intelligence. This intelligence is critical for improving the system reliability, enable the predictive maintenance, ensuring the safety and the regulations compliance, and supporting overall performance optimizations of equipment and the process. If you look at the key functions of the condition monitoring system, it starts with the data acquisitions and storage, collecting the signals such as vibration, temperature, pressure, current from the sensors. So those will help for executing in the conditioning monitoring. Now with this, what is maintenance and why it is necessary? So before we go deeper into the condition monitoring and predictive maintenance, let's take a step back and understand what we mean by maintenance. Maintenance is defined as the combine of all the technical, administrative, and the managerial actions taken throughout the entire life of the asset or the product. The objective is either to retain the asset in a healthy operating condition or to restore it to a state where it can perform its required function. In a simple term, maintenance is everything we do to ensure that the equipment continues to do what it is supposed to do, reliably and safely. Broadly, maintenance activities fall into a two basic category. First, keeping the asset running. This is about the preventing failures through inspections, servicing, and monitoring. The second is fixing the asset after failure occurs. So this is corrective or breakdown maintenance, where action is taken only once the equipment has already failed. So traditionally, industry were relying heavily on the second approach. However, as the system become more complex and the downtime of the that's we can call is a shutdown time more costly, there is a clear shift towards the preventive feature rather than reacting to them. This is where the condition monitoring and the predictive maintenance play a critical role, enabling us to move from fix it after it breaks or fix it before it fails. Now let's look at why maintenance is so critical for any industry operation. Maintenance is not just a technical activity, it directly supports key business and operational objectives, mainly in terms of reliability, cost control, and the safety. So first, enhancing the reliability and the availability. Proper maintenance helps minimizing unplanned downtime, which is one of the biggest source of production loss. When the assets operate reliably, we can boost overall productive and ensure consistent performance. The regular maintenance also helps extend the lifespan of the asset, protecting the long-term capital investment here. The second is controlling cost and resource management, that is again efficiently. So planned maintenance significantly reduces the emergency repair cost, which are typically much higher than the scheduled maintenance. Well-maintained equipment operates more efficiently, helping to optimize energy consumption. The maintenance planning also improves inventory control, ensuring that the spare parts are available when needed, sometimes without excessive stock. It can also benefit it to the organization. The third, ensuring the safety and the regulatory compliance, which is very critical in almost all the organizations. The poorly maintained equipments poses, the serious risk to, personalize the safety. And maintenance helps identifying and mitigating this potential hazard before they lead to accidents. It also ensures compliance with regulatory and the industry standards, which is essential to avoid legal issues, penalties, and reputational damage, which is very critical again. In summary, maintenance essential not only keep machine running, but also ensure the safe operation, control cost, and achieve the reliable, sustainable performance. This is why industries are increasingly moving towards the conditional-based predicting maintenance strategies. Now let's look on the types of maintenance. When we talk about maintenance, it is generally implemented through two broad strategies: the reactive maintenance and the proactive maintenance. Let's start with the reactive maintenance here. As name suggests, this approach follows the principle of run to fail. Action is taken only after equipment has already failed. While it may appear simple and low-cost solution initially, but reactive maintenance often leads to an unplanned downtime, the higher repair cost, the safety risk, and the secondary damage to the equipment. That is very critical for the surrounding equipments if the main equipment is failing. It also results in a production loss and unpredictable maintenance workload. The second approach is proactive maintenance. Here, maintenance activities are planned before the failure occurs, and the goal is detect early signs of degradations and take a corrective actions at the right time. Maintenance strategy have evolved significantly over time. Driven by increasing the system complexity and the need of the higher reliability. So let's start with the preventive maintenance, also known as a time-based or a use-based maintenance, which was widely adopted during the 1950 or 1970s timeline. In this approach, the maintenance activities are performed at a fixed time intervals or after a predefined amount of uses. Such operations like hourly, cycle by cycle, the calendar time. So the objective is to prevent the failure before they occur. While preventive maintenance is more efficient the reactive maintenance is often leads to over maintenance, where the components are replaced even though they are still in a good condition, resulting in a higher cost and unnecessary downtime. As industries began seeking more efficient approaches, the conditional based maintenance is coming picture. That is somewhere emerged during the 1980s to 1990s. The CPM is based on the actual condition of the equipment rather than the fixed schedule. So earlier cases was run to failure, the fixed schedules like time-based or the use-based. But we are considering here the actual condition of the equipment. Using the data from sensors and the inspections, such as vibration, temperature, pressure, or any electrical signals, the maintenance is performed only when the indicators are shown the signs of the degradation, whether it is degraded or not, and action will be taken accordingly. This approach helps reduce the unnecessary maintenance, improve the asset availability, and focus resources where they are truly needed. And these all are considered as a traditional strategies, but still in effect. Building on the condition-based maintenance, the next major evolution is predictive maintenance, or PDM. We can very shortly derive it, which has been widely adopted from 2000 to present. Predictive maintenance uses a historical and the real-time data combined with the advanced analytics and the machine learning to predict when a failure is likely to occur. Instead of just detecting abnormal conditions, PDM estimates the remaining useful life of component, which is very important over here. It can predict the useful life of the component and enables the maintenance department to take action at the optimal time. So that intimation is also can be given to the appropriate maintenance department in advance, so they can be ready for the upcoming challenges. This approach significantly reduces the unplanned downtime, improves the asset reliability, and helps to optimize the maintenance cost by avoiding both premature replacement and the catastrophic failure. So with this, we can significantly get the benefit on the premature replacements, because sometimes the parts are healthy in a good condition, but still, as it is scheduled, we have to replace it based on the guideline or the rules defined. As digitalizations continue to advance, we are now entering the era of prescriptive maintenance. So, which is very well known as RXM, which is just emerging strategy in the 2020s and beyond. Prescriptive maintenance goes one step further than the prediction. It is not only identifies what will fail and when, but it also mentions what actions should be taken to achieve the best outcome. By leveraging the optimizations algorithm and the digital twins, the RXM can suggest a specific maintenance actions, operational adjustments, or even automated responses to prevent the failure or minimize the impact. This table illustrates the evolution of maintenance moving from a reactive mindset where we wait for the failure to proactive approach where we schedule the repairs based on the time or the uses. However, the real shift occur in the bottom of half, where we move from simply monitoring current conditions to predictive and the prescriptive strategies. By using the machine learning to forecast the remaining useful life, to prescribe the best course of the action, we maximize asset uptime while minimizing the unnecessary maintenance cost. So moving further, this is an analogy of understanding. Sometimes the concepts might be very complex and critical between the predictive and the prescriptive. So this can help us to understand the difference between all the different maintenance type and their role. How can we analyze or analyze, or I would say correlate with the real world. So here, if I consider this run to failure, that can be act as an emergency role. The patient arrives with unconscious or might be a critical state. It is immediately we have to be act on. So there is no any other options available. If I'll consider the preventive maintenance, that is a kind of annual health checkup. The doctor schedule a physical examinations, yearly or might be twice yearly, or like the vaccinations we are considering over here for the infants. And the condition-based maintenance, that is the nurse and the home monitor. The patient or the nurse routinely checks the monitors the patient's blood pressure and the blood sugar levels multiple times a day, which is very common when the patient is admitted in the hospital. It is reading, the exceeds a specific thresholds, then they trigger. So for example, if the BP is high, they will trigger. Okay, now what can be the next action taken because of this influence? And then accordingly, the doctor will be propose the medications. Predictive maintenance, which is act as a role, the role of the diagnostic doctor. The doctor runs the test and predicts you are at the high cholesterol and will have a heart attack in 5 years. This is something based on the results they predict. Whereas the prescriptive maintenance, that is the treatment specialists, we can say here. The specialist says, start this specific diet, prescribe drug with the cost difference and the exercise for the 30 minutes a day. This combined will be prevent the heart attack and the saving the medical expenses. So this is something which I would like to just highlight over here. So when we will move forward, you have a very clear idea about the predictive maintenance and the prescriptive maintenance, which will be playing a key role nowadays in the industry. Maintenance efforts today are no longer driven by habit or fixed schedules. They are prioritized and scheduled based on the risk. As its core, the risk is calculated using a simple but powerful equation. The risk equals the probability of failure multiplied by the consequence of failure. Any of the value which will be a critical or higher, the risk is higher. If both are lower, then only the risk can be considered as a low. This approach allows organizations to focus their limited resources where they matters most. High risk assets, those they are both likely to fail and would cause a significant impact. If they do, receive the greatest attention. These assets are typically managed using the advanced strategies, which can be considered here like a condition-based monitoring, preventive maintenance, and even a prescriptive maintenance, where the decisions are driven by real-time data and analytics. On the other hand, if the low-risk assets may be intentionally allowed to run to the failure, this is not a negligence, it's the optimization. By accepting the failure, where consequences are minimal, we free up time and budget and the expertise to protect what truly matters. Like we can take an example of the bulb at home. So we are allowing it to run to fail. And once it fails, we replace. As we move towards more advanced maintenance strategies, it's important to recognize that the predictive and the prescriptive maintenance do not exist in isolation. They are highly reliant on the digital data foundation provided by the condition-based maintenance. So condition maintenance is the foundation for these two, predictive and the prescriptive maintenance tech strategies and the technologies. Condition monitoring, the sensor data and the asset health indicators from the backbone that enables accurate predictions and the intelligence recommendations. Without this foundation, advanced analytics simply cannot be delivered a value. So in short, risk-based maintenance aligns reliability, cost, performance, ensuring the right maintenance strategy is applied to the right asset at the right time. So the PF curve and the science of the maintenance optimization. The image illustrates the classic PF curve, where the P represents the potential failure. This is the earliest point when the defect or the abnormal condition can be detected, often through the conditioning monitor, definitely, like a vibration analysis, temperature measurement, oil analysis, or other sensor data. At this stage, the asset may still be operating normally, but signs indicate a failure is developing. The F represents the functional failure, the point where the asset cannot no longer perform its intended functions. At this stage, the failure is obvious and immediate action is required. Unscheduled downtime or the emergency repair is usually necessary here. So I would say here, the reactive approach at the very later stage of this curve is required where the functional failure is associated. In middle, the preventive and initially the predictive. So this is how actually we have the time between the potential failure to the function failure. We can take actions necessarily actions where we can correct the observations or the readings, or we can correct the fault or the failures. Now you can see here the difference. The curve is prolonged with the presence of the prescriptive and the predictive maintenance or the strategies. The goal of prescriptive and the prescriptive and the predictive maintenance is not just to detect the failure, but to act in a way that delays the functional failure, extending the asset's useful life. So the predictive maintenance uses the real-time data and the analytics to predict when a failure might occur. Whereas the prescriptive maintenance takes a predictive insights a step further by recommending the specific corrective actions. So if we can prolong this potential to functional failure, that we have sufficient time to correct the failure on the available schedule or the timeline and the asset and the, I would say, the spare part availability. Sometimes the spare parts are very critical to get, having a long lead time. It will be a very critical in those scenarios for a long downtime where the business will be affected. So from here, I would like to take to a real world challenges and how those are addressed smartly with these different maintenance strategies in action. So let's say the example of the high voltage circuit breaker, its operation and the control. The circuit breakers are critical assets in electrical systems. And that, of course, their contexts where over the time due to arcing, mechanical stress, and environmental factors. Failure can lead to outage or equipment damage, so maintenance strategy matters a lot. So maintenance strategy progression on the circuit breaker mains and the arcing contact over the period of time. So circuit breakers are the critical assets, in this sense. Here, the arcing contacts are very, very important for the safe operations in the grid. Earlier, the approach was towards run to failure, where the challenges was it was unplanned downtime, and that in that it can be replaced even after the catastrophic failure. The preventive maintenance was to resolve this issue at certain extent, where the cyclic inspection comes in action, where the every 5 years or 5,000 operations of the uses, the contact will be replaced. That was having, at certain extent, the planned downtime. And the condition-based monitoring for the same contact and the later of the era of the inventions, it was triggered when the parameters related to the contact were exceeded. Like the contact resistance are indirectly measured of the circuit breaker. And the travel and the operating time of the arc was also indirectly measured. And that was give an idea that how exactly the condition of the contact is. That is the indirect method. Later, the predictive maintenance came, and it was able to forecast the remaining useful life of the contact by having some analysis and the algorithms implemented, like the interruptions, cumulative interruptions, and the energy absorbed by the contact. And this will be helping for at least estimation the timeline on which we can take a maintenance or a downtime. Whereas the prescriptive maintenance, which will be introduced in action with a help of the point on wave switching, where we can optimize and we can optimize the control stress, or I would say we can control the stress on the contact, and we can optimize the life of the control. So the remaining useful life of the contact is increased. Let's see how exactly we can have this in the field. So what kind of stresses are there on the contact? So during a fully discharged capacitor closing operations with grid, immediately a following step voltage changes. The recovery oscillation starts. The frequency of this waveform depends on the relative values of the inductance and the capacitance in the system. This typically is discussed later in the somewhere in the same document. Typically, the frequency of the oscillation is usually few hertz and sometimes slightly higher, approximately 1 to 2 kilohertz. Depending on the size of the capacitor and the system impedance, the large capacitor banks results in a low frequency ringing, while the small banks result in the higher frequency ringing or the transients. The initial peak of the voltage can have a magnitude of up to a 2 per unit in the system. When breaker opens for a shunt reactor operation, the stored magnetic energy in the circuit is suddenly released, and this energy transforms into damaging the electrical overvoltage, causing the arc to the reignite repeatedly. Each restrike subjects the contact to intense thermal and the electrical stress, leading to excessive contact erosion. So the main and the arcing contact both can be realize this stress and have a erosion, which can affect the life of the contacts. Here, the pre-strike and the restriking the arc is also important to understand. In general, are particularly damaging near the current zero crossing, where the transient voltage peak. These arcs repeatedly stress the contacts, reducing their life reliability and can even prolong the transient over voltage into a network. So in essence, while shunt opening, capacitor closing, and the other switching operations are necessary for the system control, they introduce a significant stresses on the breaker contacts. Understanding and mitigating this effect is critical for extending the contact life and ensuring the reliable operation. So point on wave switching. This is the concept implemented as a preventive and the prescriptive maintenance in a technical approach for dealing the operation with the breakers. So the solution to this problem is this. The wave switching carefully controls the voltage and current waveforms during a switching operations by synchronizing the breaker operations with the voltage waveform. It minimizes the pre-strike and the restrike arc, reduce the transient over voltage, and significantly protect the contacts from the erosion. So breaker time is defined, and the additional delay for a control target point might be a zero of the sine wave or peak of the sine wave is achieved by calculating all the operating time factors affecting the operation, the closing and the opening operations of the circuit breaker. So for example, here, if the random input is given to the device will be calculating the additional delay that ensure that the breaker will be open at a zero crossing or close at the peak of the wave. And there, these determinations can be taken based on the load conditions. So whether the capacitor is as a load, which will be connected to the grid, or the inductive or the reactor as a load connected to the grid. Even the transmission lines can also be connected with control switching, and the transformers are also energized with a control switching. So the parameters, these are the list of the parameters. So from random input commands to the synchronized breaker operations, the target delay is derived from a different circuit breaker parameters with operation time factor. So you can see the line frequency, that is the frequency of the system, will be considered as a system reference. And then the delay which we have seen over here will be introduced by the all parameters which are listed from second onwards. So that is the SF6 gas pressure density. The control voltage itself is also operating, the influencing the operating time. Ambient temperature, the ideal time, the time since the last operation done. Store energy, Or if it is an air blast circuit breaker, the actuator's pressure of the air, the pre-arcing time, which is influencing the closing operation. So you are targeting to the peak of the wave to close. But if the arcing is presence previously, like the pre-arcing is happened, then the electrical contact happened earlier than the peak, and then there will be consequences and the stresses on the contact. Similarly, there will be a reignition free window. That we need to ensure for the opening operation. So this all will be having the impact of on the operating time delay, which will be introduced by the point on wave switching device. And finally, the breaker will be operated at the target point, whether it is a zero crossing or the peak of the wave. The adaptive correction, the last one. After every switching operations, the point on wave controller or the device measures the actual closing and the opening instant and compare it to the target instant. And this can be done with the auxiliary contacts available with the breaker. It then uses the error to automatically adjust the timing delay for the next operation, thereby tracking the long-term changes like a mechanical wear and that aging, which are not covered by a 4 major parameters. So this will be taken by this adaptive correction. Those are not addressed apart from the listed parameters will be having the impact on the timeline, and that can be over the period of time cumulatively adapted by this adaptive correction algorithm. So the control closing is the technique of controlling the instant of making with the inspect or to the system voltage waveform. Again, the phase angle is matter a lot for the all three different poles of the breaker. A typical timing sequence for the control closing of an independent pole of the circuit breaker is illustrated in the figure, where the target is the voltage zero. So closing time, again, it can be same if all poles of the breakers are operated by the same drive, or it can be different if the different drives or the different controls are there for the breaker. Those different times and the delay, including this, the phase wise and the all parameters we discussed earlier, this final target is achieved. For example, here it is the voltage crossing, zero crossing at the voltage signal. So if it is not targeted at the zero, the oscillations which you can see might be significant, and which can lead to a contact to a early erosion. In other terms, reduce the life of the contact, the available life of the contact in the field. This is something for the closing or the energization. Let's see for the control opening or the de-energization. So here again, the opening time might be same or different for all the three phases, and the delay will be added. And also here, the arcing time, which we discussed, it's a reignition free window, which can also be considered over here. So the arc will not going to be a restrike or a reignited. The very important note here, this all machine learning techniques does not replace the critical protection logic of the breaker, like instantaneous trip when the fault occur or the thermal overload. And this must stay deterministic, that for the safety and the standards compliance. So ML should not run as a supervisor. Yes, here it can be only running as a supervisor or advisor system, not as a sole protective mechanism. These are the practical examples in the field where the control switching's algorithms are implemented, which can save and minimize the stresses on the contact and increase the useful life of the breaker. So while reducing the stress on the contact, not only the contact wear and tear is addressed, but it is also addressed the overall stresses on the breaker and the breaker operations. So it is a smooth. So not only the contact, but also the other parameters or the other components of the breaker will be having a less stress, like SF6 breaker. It will be having a low degradation in the quality. So the life of the SF6 pressure will be, the gas will be increased. At every operations, there will be degradations in the quality of the SF6 gas. And at some times and after some cycles, it is required to refill the SF6 in a routine, as a routine. So by introducing this kind of control switching techniques, the degradation of the gas is reduced, the pressure remain maintained for a long time, and the refilling time cycle is also, I would say, reduced. This is something which is the very best example in the industry where you can see the application of the predictive and the prescriptive maintenance, how it can help to prolong the life of the components of the breaker. This is the one example which is in practically implemented in the field. I would also like to touch some other examples of the industry where the optimize is the device for conditioning and the monitoring purpose, which is in market. So if we see any like the for the product, like the PF curve we have seen. Similarly, additional to that PF curve, we also have the curve which will be showing you the energy waste as well as the cost to repair at the later stage. So between the potential failure to the final failure or the when the unit will be completely stop working, the functional failure. In between, we have a time to detect and take actions. This device will be helping to monitor the vibrations, temperature, and along with the Bluetooth pressure sensors, it can also measure the pressure of this water pressure of the system. So early detections, with this, we can have a 90% saving on the maintenance cost. Rather waiting for the machine to fail. This product is having some features that's for the condition monitoring of the mechanical and the electrical assets, like the rotating machines, whether it is a pump or a motor. It can provide the location, the maintenance log, manufacturing data, and the reminders as and when the values crosses the thresholds, like the vibrations are extreme high or the temperature is higher. And this is simply optimizing the reporting, that helps to simplify the documentation, the manage the system maintenance, and inform the purchasing. So if any of the component is required to be procured in advance because of these high vibrations, it can predict whether the algorithms are implemented in such a way that it can have a machine learning done. So it can predict whether these vibrations are because of the bearing failure or because of the cavity in the impeller or because of some misalignment done between the motor and the pump. So all the signatures of the vibration data are helped to analyze this in a better way. It is also having some the IoT enabled capability to connect with mobile and the cloud. So the remote monitoring and observations are also possible. All data will be available to cloud. We can have again the opportunity to implement the AI in this and make it even more intelligent. So identifying the fault, the probability of the fault. From there, it can check the ERP system of the organizations where really a bearing is in stock or not. If not, they can detect on an early stage and the procure the bearing in advance. So at the functional failure, there will be no a big downtime. I would say that no longer downtime can be faced by the organization. It can also prescribe to the machine control device like a drive that because of this bearing failure, if the machine will be operated at 80% of the speed, the bearing life, the bearing failure time can be managed or can be increased. So such a very important decisions can be taken, as and when these faults are occur. So something is in stock, we can take the immediate call, we can replace and go for a smooth operation. For example, if the component which is going to be failed is not available in stock, so it can be a prolong the time between the potential failure to the functional failure and get those materials in a store by procuring it within that time frame. So we can replace and then continue the operation. So the operation will not stop because of the unavailability of the component, which is going to be failure. So here, let's say have the idea about how exactly this is functioning in the field. So similarly, this is the device which can monitor monitoring and diagnostic the fault on the machines, especially the rotating machines, and intimating in advance for any critical actions is required. Might be a replacement of the component or any replacement of the entire product. So that will be giving us idea about the health of uh, the product on which it is mounted. It is a magnetic mount device, can be very easily mounted on the magnetic body, which can be supporting to the magnet. So sometimes the machine's bodies are electronic aluminum body. There it is difficult to mount these magnetics. So in such cases, instead of the magnets, the screws are mounted through the screw. You know, they're using
Excuse
the
me,
screw.
sir.
We can mount this device. Yes.
Excuse me. It is not visible on the screen.
Yeah, I'm just just explaining
Oh,
about
okay.
the device. Yeah.
Okay, okay, no issue.
So this device will be giving the idea about the vibrations and the parameters which we can measure in the 3 axis. The courtesies RFFT and algorithms are implemented. So those are the latest technology associated with this analysis. The temperature and the pressure sensor over the Bluetooth. It has a capability to connect two Bluetooth sensors with this device, so it can measure the pressure, water pressure of the system. It is also having the capability to monitor the shelf life. So if the battery which is powering this device is having at the end of life, it can trigger alarm and the warning through which the operator will be having idea to replace and continue the operation of the device on the machines. Would like to touch one more product. There are many actually, but with the time constraint, I would like to consider a few select products where this predictive and the preventive technologies are implemented. So this is extending the life cycle of the motor pump set by introducing this product. This product is again optimizing the performance of the pump for the the first class pump management methods and algorithms. So let's have this product overview.
Excuse me, does it, sir? Excuse me. Does it, sir?
Yes.
Yeah, voice is not
Yes,
coming
yes.
actually.
So for all the videos or only this
Yeah,
video?
for all the videos. I think when you share, na, at that time it has to
Okay.
be one switch is there.
Mm-hmm.
Maybe that is the
Okay, so
reason.
at least it should be intimated in advance. You have to stop me earlier.
Yeah.
Hmm. Okay. So
Or you can stop sharing and then again share. At that time it will
yeah.
show.
So let me share once again.
Include
Because
sound. There is a yeah. Include sound on the share.
let's put yeah.
Right and top.
Yeah. Yes.
Yes.
If it could have intimated early, I would say it
Actually,
was
I was.
great. All the videos because those were very interesting. So would you like to see the videos which you have missed, or you would like to continue from here? Because I would say there are no much slides. We can
This one can
have
be.
to. Yeah.
Yeah, now it is coming.
Xylem is a leading global water technology company committed to solving critical water and infrastructure challenges through innovation. Hydrovar X offers the right combination of motor, variable speed drive and pump, ensuring great performance, maximum savings and a rapid return on investment.
Experts and new generation of users share a deep focus on high-efficiency solutions. That must be easy to use, compact, connected to the smartphone, and with always an eye on the savings. Hydrovar X answers all these needs.
The main values of Hydrovar X for our customers. It's simple, save time on your transition and management. It's sustainable, reduce your energy footprint. It's intelligent, optimize performance and reduce lifecycle costs. It's flexible, implement across a variety of applications and pump solutions. It's future-proof, all the values mentioned in your hand on your smartphone through the app.
Hydrovar X is simple to program. Install the pump, set the set point, and you are done. Do you want to fine-tune the configuration? Follow the on-screen genie or find all the parameters you need in a well-organized menu that provides what you need in a few steps. Is the pump display too far to reach? Connect your smartphone to configure the pump from a comfortable position. It's so easy.
Hydrovar X is sustainable. The entire design has been developed from a different perspective, keeping sustainability as a priority from the beginning. No rare earth metals are used for an incomparable impact in environmental footprint, and at the same time utilizing i5 motor for best-in-class level of efficiency. Hydrovar X optimizes performances and reduces lifecycle costs. The fully integrated solution exploits the full potential of the new motor technology and overall performance of the pump unit. The intelligence inside the unit and automatic algorithm included will help the user to properly set up the unit quickly and reduce lifecycle costs.
The first solution we are offering are for pressurization systems, for instance in industrial and building services environments, such as through our ESV, HM, SVI and booster families.
Hydrovar X is future-proof. We are in a new era for technology where customers don't need a product but demand a solution that's easy and effective to install and run. With this in mind, we are today offering a comprehensive range of new features that have their roots in Hydrovar know-how. Such expertise is then mirrored from each unit onto the mobile phone app that more and more users are already using.
In terms of communication protocols, having a plug-and-play solution is of course a plus. And unlike the other families in the electronic portfolio, a key feature is the flexibility of the embedded Modbus RTU and BACnet MSTP. Everything is already in the brain of your pump, the drive, but more is yet to come.
So here I would like to just take back for the video was not available for the optimized product. So let's have the look on the video how this product is performing in the field. So the optimize is also having, as I mentioned earlier, just by having the look of this video, I would like to just say this is the sensor which can be connected on the wireless. So the capacity is to connect the two such a type of sensors on the wireless wirelessly with this device, which is mounted on the pump, where it can measure the for example the pressure on both sides, the suction and the discharge. So you can see some pressure gauge or some pressure sensors are mounted over here, which can communicate on the on the Bluetooth or to this device. It can be further communicated to cloud, mobile apps, where it can be having more features to be implemented. So these applications are more mature day by day, which can playing a critical role in the predictive and the prescriptive maintenance of the machine. So let's move on from here. Like HydroVar X, we have seen the product. We would also like to here touch the smart world technology, which is that detecting the leakage in the pipelines and any kind of a failure. So it is having a very precise accuracy to detect, which is having the acoustic sensor inbuilt, which can be sensing the small leaks or the gas pockets within the water line. And it is a very easy to deploy in the system and not having additional cost on this. So let's see the performance of this device in the field. So such a second video available for the same, which will be also for the smart ball. Just giving the idea about. So let's have a discussion now.
The Smart Ball inspection platform is a ball that can be inserted into a pipeline, both water and wastewater, while it's in service to identify small, medium, and large leaks and gas pockets, with the goal of providing a location that's diggable. The Smart Ball tool has been around for many years and is trusted by utilities around the world for two main reasons. One is for condition assessment purposes, and the other is for reducing non-revenue water. From a condition assessment perspective, Smart Ball is a proactive tool that can be part of a larger holistic approach to help identify problem areas that can be repaired before they turn into bigger issues, and to prioritize capital spending. On the non-revenue water side, because we are taking the acoustic sensor directly to the leak, we can inspect transmission mains with a greater level of accuracy than traditional correlators. In fact, based on thousands of miles of experience, we're finding 3 to 4 times more leaks than trunk main correlators. Which means Smart Ball is a really great tool when you want to find all the leaks and reduce your non-revenue water. What makes Smart Ball so great is its ability to get into and out of pipelines very easily and to do long runs in one inspection for both water and wastewater pipelines. To insert the Smart Ball, it's put into a claw, and then we're able to actually lower the claw into the line while it's under pressure. When the ball is traveling through the line, we're putting the acoustic sensor right in the pipeline, so it's traveling in line and the acoustic sensor is going right to the leak. Throughout the inspection, our team is constantly monitoring the position of the Smart Ball to successfully navigate the pipeline and to assist with locating leaks and gas pockets. A lot of what the Smart Ball is doing is it's collecting data. So we've got an acoustic sensor that's listening for leaks and gas pockets. We've got an accelerometer and a gyroscope that's measuring movement of the ball that we can later use for pipeline mapping. We've got a magnetometer that's measuring the magnetic field coming off the pipe wall that can be used to find joints and other features in a pipeline. For a standard extraction, we have a specialized net that is used to catch the Smart Ball and pull it out of the pipeline, all while the line is under pressure and in service. Another strength of Smart Ball is the many alternative options available to get it into and out of a pipeline. Having multiple options reduces the money and effort required by utilities to support the inspection. Once the inspection is complete, the data is extracted from the ball and it's sent to the data analysts where they will identify and locate leaks and gas pockets. It can be expensive to dig a hole, and so what we want to do is provide information that's accurate so clients can go and dig up the pipeline and find the leak the first time. We're really excited about the future of Smart Ball. We're looking to get more technology on the Smart Ball so that when we do one inspection, we can grab more data, more information that our clients can use from that one inspection to help manage their infrastructure. When they dig up that leak and find it, it's a big win for both Pure and the client.
Energy is vital to the function of our society. North America's 900.
Again, it's the same video. If you would like to save for the same product, I can continue as we can conclude over here for the today's session that how exactly the conditioning monitoring is influencing the latest technology and the latest product in the market, where we can very early predict the failure in the system and just avoid the downtime in the operation. Yeah. So that's all from my end. Thank you everyone for joining this call and listening very patiently.
Uh,
sharing my screen.
Okay. Any question?
One question. Abhirami and
please, Mitesh.
Mitesh, please unmute Abhirami.
Yes, sir. Done, sir.
Yes, please, Abhirami. Hello? Abhirami?
You may ask the question, Abhirami.
Okay, any question? Which microcontroller can be used for data sending to mobile application?
So here, not a specific, but the blue energy from the ST is widely used. Also, we have the ESP32 modules, which can be again a game-changing. I would say, and the not the IC but the module using in this technologies. And some other Nordic solutions are also ruled. So yes, those are the controllers are widely used for this wireless connectivity with the application.
Yes, anyone? Which microcontroller? This question you're taking. Any other question? Participant? Okay. So I have one more, one small question, Darshit sir, if you can answer, please. So I have seen that product called Optimistic. What was that?
Optimize.
Yeah. So is there a correlation between the breaker lifespan and for example, the condition monitoring equipment? I mean, transients which occurs because of when we open the breaker or close the breaker, both the times, right? Because of the system parameters and inductor, capacitor, whatever. But what is the correlation between the contact life and number of transient or the intensity of the transient?
So the intensity of the transient and the and because of the arc will be reignite or might be pre-strike before the closing the contact. So the presence of arc is eroding the contact quality and affect it lives. So in field, when in the breaker, if arc persists and if it is not distinguished on time, then there will be extensive pressures. That is the electric, I would say, electro thermal pressures on the contact, which is making sometimes the contacts welded and completely non-functional. So controlling those arc presence and very effectively quenching in the circuit breaker, this control switching will be very much helpful over there. So yeah, that is how the context lives can be reused or prolonged. Yes.
Okay, and the equipment which was used for this rotating machines like bearing condition monitoring and all that, in that it was using vibration, temperature, etc. Right?
It is having the capability to monitor the vibration, temperature, and also the water pressure by connecting the pressure sensors over the Bluetooth.
So these sensors basically they are like in many of atmospheres or environments where it is used, it might be affected by the noise also, right?
Yes.
It's a physical sensor, right?
Yes. So for that, the product body is make it the IP proof. So it is also protecting the sensors from the weather effect. So that way it is having, as it is used in the environment where the pumps and the oils are present. So in the water, the pumps can be operated, the water and the oil. Yes, so it is a proof in that sense, and tested at the extreme temperature where it can perform reliably.
Thank you very much.
There is one question. Can normal relay, which are 5 volt or 12 volt, can be used to disconnect a circuit in fault condition in home?
So it depends on the like the system which we are connecting here. So if the power which is required to be break is capable by that relay, the relay can be act as a circuit breaker. So circuit breaker is a very generic term, but yes, in the power grid we have the circuit breakers. But in a small, I would say, low power equipments, we are sometimes using the relay as a main contact to be quench and disconnect the circuit from mains.
Can we replace numerical relay which AI/ML program with?
So yes, some statistic, that some static relays are there which can be implemented in the grid. So that is on the very early stage, I would say. But yes, those switches are tried, the thyristor based, and now the unidirectional switches like the FATs and the IGBTs are playing a role in a kind of a StateCom or the other VAR controls mechanism. So yes, it is there in the field. But again, these control techniques will be helping in both the way. Either it is I would say semiconductor switch or the electromechanical switch. It can help to increase and I would say the enhance the life of the contact and ultimately the switch.
If any participants have any question and directly interact with, they can directly interact with our speaker. Please raise your hand so we can unmute you.
Step on the hold.
Hello. No question? All are actively connected? Hello? Please, we wish to take one group photo. So kindly please on your camera. Hello? Okay. Okay, good. Please turn on your camera so we can take group photo. Okay. Okay, thank you. Thank you.
Thank you very much.
Thank you very much.
Thank you. Thank you, Darshit Prajapati sir. Very interesting session. Thank you.
Yeah. Thank you. My pleasure. Thank you very much.
Okay.
Thank you.
Okay.